7th, right?
Yes.
And now we start with your questions. Any questions you want to start with? Anything I have?
I had a question about, it says simplify the exponential expression, and then they had the example of 20x to the power of 4, y to the power of 5. And I guess it's divided by 36x to the power of 6, y to the power of 7. I could not find
Excellent. Perfect example. Before we address that example, I have to explain what it's called exponential rules. Exponential rules. There are several that we need to review. So here they are. A to power m times a to power n. A to power m. So my m has 3 bubbles, my n has 2 bubbles if you want. It doesn't matter, you can use anything else. A to power negative n. A to power m, everything to power n. A to power 0. So at least let's discuss these. And then we're going to address your question. Promise. Okay? So here we're multiplying 2 exponential notations. They have to have the same base. If they don't have the same base, we cannot proceed. But they do have the same base. We copy the base. Copy the base. Nothing happens to the base. We copy it. So I copy the base. What happens to the exponents? Anyone remembers? What happens to the exponents?
Addition.
Yes, m plus n. So when we have multiplication here, we have addition for the powers. Perfect. We divide to exponential notation. They have to have the same base. We copy the base. Nothing happens to the base. We copy it. What happens to the powers? What operation we perform with the powers?
Subtraction.
Thank you. Be very careful. I'm not saying you said anything wrong. I'm just saying I'm drawing your attention to something very important. It's always from the power of the numerator, we subtract the power of the denominator, never the other way around. So from the top, I subtract the bottom exponent. What about this? Anyone remembers? A number raised to a negative power.
There's no negative exponents. There's negative exponents.
So it's 1 over a to the positive exponent. So a to negative n is 1 over a to the nth power. What about what if I have 1 over a to negative n? It's 1 over. It goes to the top with positive power. So a to negative n is 1 over a to the n. But 1 over a to negative n goes, so see, this is at the top, now it goes to the bottom because it has a negative exponent. It has a negative exponent in the denominator, it goes to the top. Next one, copy the base. What operation we perform? It cannot be addition, it cannot be subtraction, because those are taken by something else. So a to the nth power, everything to the nth power. What operation we perform now with m and n?
Multiplication.
Perfect. So thank you so much. So when we multiply, the powers are added. When we divide, the powers are subtracted. When we raise to a power, the powers are multiplied. Last but not least here, this is always 1 only if a is not 0. So what I'm telling you here is that 0 raised to 0 is not 1. Okay? So anything to 0 is 1 as long as this is not 0. Okay, now we're ready for that question. Any questions here? Any questions? Any questions? Okay, so now we're ready to work on this. And that's my page 2. 20x to the 4th, y to the 5th, over 36x to the 6th, y to the 7th. Perfect. One way of doing this, one way is this. These are all factors. They're all multiplied. We can simplify. We can simplify only factors. So let me explain what I'm saying here. X plus 1 over x minus 2. I am not allowed to do this because x is not a factor. It's not multiplied by something. It's added to something. This is not a factor. These are terms. These are terms. They're not factors. But here, these are factors. I can simplify. So be very careful. Remember this rule. We can only simplify factors, not terms. So how will it look like? Okay, I can do this. X plus 1 multiplied by x minus 2 over 3 times x minus 2. Yes. There is something very important here. I have to write that x that cannot equal 2 because this is 0, not allowed. But I'm allowed to simplify factors. Why? Because these are multiplied. This is a factor, this is a factor, this is a factor, this is a factor. Here I cannot because these are terms. So this is a side issue. It's a very important issue because we're going to get to this soon. Now, what do we do here? So first of all, I see 20 and 36. And I know that I can simplify top and bottom by 4. This is where I start. I simplify the top by 4, and I get 5. And I simplify 36 by 4, and I get 9. Then, so I already have 5/9 in front. Then I'm using the property that we discussed, x to the 4th over x to the 6th. Copy the base. That's one way. Copy the base. What will be the power?
-2.
Excellent. Here's another way. I cross out 4 from here, and I cross out 4 from here. That's another way. So then I know that I have x squared in the denominator because this is 1 and this is x squared. I can do the same thing with y to the 5th. I remove 5 of those factors from the top and I get 1, not 0. And I remove 5 from the 7 ones and I get y squared. And I'm done. Another way would just be 5/9 times x to -2 times y to -2. But then I have to bring it here because no negative exponents in the final answer. No negative exponents. So then I have to use this property now and bring them to the denominator with positive exponent. So then I have 5/9 x squared y squared. Is this okay? I didn't hear. Is that a yes? Is that a no?
No,
Which part is not clear?
I guess so. Yes, but that's what I'm saying. I understand that you got the x2, but it was what is it? What is that? It's the x is 4 from 6, and you're not supposed to flip it. Flip it. flip the reciprocal because it's in a negative, x negative 2, or maybe I'm wrong.
But negative 2 in the numerator goes to the denominator with the positive exponent. That's the rule that we just discussed.
Yeah, yes.
X to negative 2 is 1 over x squared.
Yes. Okay.
So I said this is one way to cross it out like this, or 4 minus 6 is negative 2, 5 minus 7 is negative 2, but now we have to bring them here because they are in the numerator with negative exponent, so you have to bring them to the denominator with negative exponent.
Yes, ma'am, I got that. Yes, ma'am.
You can use this method if it's better for you, or you can use this method, but then you have an extra step, which is fine, nothing wrong. Other questions for me? Is there anything else that you worked on that you need help with? So this is what we did not cover last time. Did you encounter other questions or other problems in your work that you need help with?
Hello, Moto.
Sorry about that. So is there anything else that we need to address, or is this good enough? So let me share my screen. I'm just going to the course. Where are you guys? I lost you. Okay, here it is. So tell me if there is anything else in this assignment in 0.1 that you need help with. I did not get the chance to look it up, but if you haven't completed 0.1, you can consider yourself behind. Is there anything else from 0.2 that we need to address? So this is the preview for 0.1. It should take you half an hour to finish everything now. Is there anything else you need help with here? Please let me know. If not, practice 0.2. Is there anything here that we need to address?
I saw question 15 and 16. I didn't have an answer for that one.
Okay, very good. Here in 0.2?
Yes.
Perfect. Let's take a look. Thank you. Excellent. Yes. Yes. Okay, so let me just, before we get to, we know how to plot. We know how to plot everything here. Yes, okay. Well, you didn't have any issues here. Perfect. Find 7 ordered pairs to the equation, then determine its graph. So they're giving us -3. Okay, so they want 7 ordered pairs. I don't know, does it allow you to enter more? That's silly. Okay, so remember how we did it last time. So in y equals, clear everything you have. And this particular problem was giving us y equals x squared. Excellent. So I put in x squared. I go to second and table. And now I put the numbers that I want. They're asking us for -3. I can put 0. I can put 2. I can put 1. I can put -4. I can put 5. I can put whatever. And I copy those here. I take them and put them in here. Very easy to insert the function, but remember, let me say it again, you have to have the table set in such a way that it allows you to put your independent variable as you please. So as I mentioned last time, make sure that the independent is the ask mode. Otherwise, it will not let me to type in anything I want, like it did here. Okay, stop me if you have other questions. The same.
How do you get the table? Hold on, I'm looking for the table.
So you go here to second and table set. Second and table set. Do you have it like this in the ask mode?
So I got it.
Yes.
Yes.
Perfect. Then you go to second and table, the last one, second and table. But you have to have in y equals this. If you don't have anything, then you cannot enter anything. So go to y equals first and enter x. This is your variable right here next to alpha. And then the power 2 is here. So this is your x and this is your power 2 or squared. Okay?
Yes.
And then you go to second and table and you punch in whatever you want. You can also click on graph. So exit, always exit with second and quit. Second and quit. Quit is right here next to second. Second and quit. And now you can click on graph. But before we click on graph, I want to show you something here. When you click on window, what does this mean? Let me stop sharing for a second. So when it says window in the graphing calculator, it will basically tell you the edges of the viewing window. So this is the y-axis, the x-axis, and 0. So if the viewing window says -10, 10, 1, what does this mean? This point here at the leftmost edge, if you want the left edge of the viewing window, this is -10. This one is +10. And what is this? It's the tick mark. 1, 2, 3, 4, 5, 1, 2, 3, 4. So in other words, this is 1 because it could be 2, it could be 3, it could be 10, right? -10, 10, and the ticks are at 1. And it says by, and now it gives us the same thing for the y-axis. Whatever. Well, let's say for the y-axis, -3, 3, 1. Which means this is -3, this is +3, and the tick is 1. 1, 2, -3, 1, 2, +3. So the first one is always for x, and the second one is always for y. Do we understand this? Is that a yes? Is that a no?
Yes.
Perfect. So back to sharing here, sorry. So I can give the calculator the viewing window I want. So let's say I'm okay with -10, 10 with a scale or the tick mark 1, but I'm not happy with y. I just created that in my example. I want -3, I want 3, and I want 1. Once I adjust the viewing window to what I wanted it to be, which is not appropriate for the function we have, but let's say, bear with me. So I click on graph, and this is the graph. -10 is here, +10 is here, -3 is here, +3 is here, because that's what I chose. But I can go back to window and say, no, I'm happy with a square window, -3, 3, with a scale of 1, and the graph will look a little bit different. But it's the same thing. -3 to 3, -3 to 3, and the tick is 1. The tick mark is 1. So this distance is 1, this distance is 1, and so on and so forth. So that's the idea of the viewing window. So quickly, let's get to what we were asked to do. So you have no issue to enter these numbers and get the graph of this, right? Don't say yes if you want me to work on any of this, right? You let me know. Well, the same thing. How do I put the absolute value? Okay, so if I want to go to y equals and clear, here's the clear button. Go to math. Go to numbers. Here it is, ABS. So absolute value of x, and the function was +3. And I put +3 outside of the absolute value, careful, +3. And I want to graph this. And I like the standard viewing window. The standard is in zoom, and I want standard. Standard is the -10, 10, -10, 10. That's what the standard is. And I press enter. Graph it for me. I didn't click on 6. Here it is. That's the graph of the absolute value of x plus 3. Negative 10, 10, negative 10, 10, and the tick mark is 1. Because that's the standard viewing window. How do I see it? Right here in window. Negative 10, 10, negative 10, 10, that's the standard. Okay, back to, finally, let's get to what you were asking. So the same thing, no issues, I hope. No issues, I hope. You just have to enter y to the third. How do you enter x to the third? So here it is, clear. X caret is the power, anything but 2 or negative 1. Caret 3. Come down from there in order to continue with negative 8. Negative, this is not the negative you want, this is only the beginning negative. But this is not the beginning, there is something else in front of it. Okay, and then you can graph it. That's the graph. Okay, 12. Okay, so this is your viewing window. Now you know how to create the viewing window, right? Negative 8, 8, 1 and negative 5, 5, 1. How do I do that? Go to the window. Negative, see, I start with this. When there is nothing in front, I have to start with this, negative. Negative 8, 8 with a scale of 1, negative 5, 5 with a scale of 1. That's the viewing window. Okay? So you have to, obviously, it's not this. 1, 2, 3, 4, 5, 6, 7, 8. It appears to be this. I'm checking. This is not it. I'm checking. This is not it. This is it. Negative 8, 8, negative 5, 5. 1, 2, 3, 4, 5 with a tick of 1. Okay, finally, 13. Can everybody follow this? Don't let me move on if you have questions, right? Good. So we finally got to the question. We have a table of values here. We have x, and we have two different functions, y1 and y2. And I need to explain something. First, let's take a look. Let me see my video.